All right, notes 4.3. I'm going to call it imaginary number. Let's see, imaginary and complex numbers. Imaginary and complex numbers. All right, well, unless you took data analysis with Ms. Bauer, you've probably never heard of imaginary numbers or complex numbers. Okay? So two new things here, but I promise you none of them are terribly difficult. Okay? But you have to know what imaginary numbers are before you get to complex numbers. Okay? So let's start with that, kind of like a definition. All right? Imaginary numbers. Okay? Now, I'm not talking about like your imaginary friend when you were a kid. Did anybody have imaginary friends when they were kids? Or is that just me? I had a sister, and we like together we had multiple imaginary friends. Like you couldn't see them, but we pretended they were there all the time. Okay, that's not what imaginary numbers are. They do like they're not invisible. All right, you will actually see something that represents an imaginary number. All right, so imaginary numbers happen. All right, when you take let's say the square root, and I'm going to put in parentheses, or any even root. All right, so that means square root, fourth root, sixth root, okay? So they happen when you take the square root or any even root of a negative number. Okay? All right, now, let me show you, let me talk about why, okay? Do any of you guys have a calculator handy? Yeah? Okay, type in the square root of negative 16. Type that in. Tell me what you get. All right, Remy, I see you're saying 4, but there's a negative 16. So I just want you to tell me what the calculator tells you. All right, Mickey says undefined. Some calculators will say error. Okay, good. That's what I wanted it to say. All right, that's because the calculator can't take the square root of negatives because they're imaginary. All right, and so we are going to have to, or non-real answer. Yes, some of them say non-real because imaginary is not the same thing as real. Okay, everything we've done up to this point in math has been a real number. Square roots, fractions, decimals, they're all real because the calculator can spit out an answer, okay? But the calculator can't spit out an imaginary answer, all right, even though it exists. And the reason it exists is because square roots of negatives kept happening, like in the realm of math over the years. There were so many square roots of negatives. Mathematicians back in the day were like, this can't happen that much. We have to figure out a way to represent it and then keep going, okay? So the reason it's called imaginary is because when you take the square root of a negative, the answer gets an I in it, like the letter I, okay? And so let's write that down, all right? So there's a rule, all right, that mathematicians came up with years ago that said the square root of -1 is equal to I. Now, you will only see it as a lowercase I anywhere, and most of the time it is not just a straight up and down, okay, because they want to make sure that it doesn't look like a 1 or anything like that. So I use what I consider a cursive lowercase I, okay? I think on Alex, it looks more, change back to my pen. I think on Alex, it looks more like that, okay? But it's a cute little I, All right? Okay, so if the square root of -1 is I, and I can technically write any square root of a negative like this. So I'm just going back to my square root of 16. Technically, I can write any number that's negative as -1 times the positive number. Okay? You still with me? And so anytime there's a negative underneath, it's really the square root of -1, and that makes an I. Okay? And then now you have the square root of a positive number that you can actually work out. Okay? And so in this case, the square root of 16 is, Remy told me earlier, 4. And so if this is 4 and that is I, and they're multiplied, then my answer is 4I. But the calculator cannot tell you the answer is 4I. It's going to tell you error or non-real or undefined or something like that. Okay? All right, so then how does it, like, what is really the process? Okay? Because you don't have to actually write this step for every single problem. Okay? You just have to understand that that's what's happening. Okay? So what you're going to do, all right, is, like, in terms of steps, if there is a negative, okay, in the radicand, remember that's fancy for the stuff under the square root. So if there's a negative in the radicand of an even index radical, right? Index is the same thing as root, right? So if there's a negative under an even root, okay, you're going to pull out an I, okay, and cancel the negative. All right, so that negative turns into an I, and then the negative's not there anymore. Okay, and then you're going to simplify the positive radical. All right, so we're still not getting decimals for these. We're still going to break them down and look for factor trees. It's just most of our answers are going to have an I in it. Okay? Now, I do want to add a special note to this. And my thing's not being friendly here. Just a little special note. If the index is odd with a negative underneath the radical, the answer is just negative. And I will explain why when I show you an example of that. Okay? All right, so you're only going to use an I when it's an even root of a negative. Okay? All right, so I've got a couple of examples for us to look at together. All right, so you know we always like do some practice. Okay? All right, so let's just start with the square root of -8. All right. We should all be able to type something in the chat box really quick. What letter is going to be in our answer? That's 3 people. What letter is going to be in our answer? 4. There's a bunch of you. More than 4 people. Come on. In the chat box, what letter is going to be in our final answer? The weird I. I love it. Okay, yes, I. All right. And so if you want, you can go ahead and cancel out the negative and put an I in front, and then forget it, and then like you're done with that, and then you break down the radical. Okay? All right, so break down the radical means make a factor tree and look for your sets. All right, now I need sets of how many for this one? Sets of how many to make a circle? Good. Now, when I take something out, it just goes in front with the I. It just goes in front with the I. So my answer is going to be 2I, and then I have a leftover 2. Questions? All right, let's do another one. How about the square root of -48? And I'm going to throw some other letters in here. I don't know how often you'll see it, all right? But the process is the same as if it was, you know, when we did it with all the other letters. All you have to remember is that this negative is going to make an I. And then you break down everything else as if it were normal, because it is normal. Okay? So take a minute and try that before I tell you the answer. Okay, so how many circles can I make? Good, some of you are with me. All right, I can make 2 circles of 2s, which means what number is coming out? Good, Jordan. Mickey, good. 4 is coming out, right? A 2 times a 2, all right? Now, the only thing that's already out front, because the 2 is circled, that was problem number 2, all right? So that just means I'm going to have a 4I in front, okay? All right, now, I know I'm going to have leftovers, but I need to take care of my letters as well. All right, how many sets of X's can I take out? Good. I really appreciate those of you that are either typing it in or holding up your fingers. Like, at least you let me know you're with me. I wish more of you would do that. Okay. How many sets of Y's can I take out? Awesome. Yes, I love it. Lots more hands went up that time. Okay. But there are leftovers, right? There was, let me get a different color. There was a 3 left over, and there was an X left over. Okay? Anything else? Any questions, concerns, comments? Could we put the X and Y in front of the I? Absolutely. Absolutely. In fact, I was getting ready to say, like, if this were a multiple choice question, I don't know where the I would actually, like, depending on who typed it up, I don't know where the I would fall. Like, it could fall anywhere as long as it's in front of the square root somewhere. Good question. Good question. All right, let me give you another one. All right, now this one's a little different because I put a negative in front, but please don't let that change how you do the problem, okay? You are not allowed to multiply those 2 negatives together because one's not under the radical and the other one is. So all this does is the negative underneath makes an I. The negative in front is going to stay in front. Okay? All right, does 3 have any pairs in it? Am I going to be able to start make any circles, any sets? Good. A head shake? Yes, no? No? Okay, good. All right, but how about the A's? How many sets, and there's a lot of them, how many sets of 2 can I make out of the 15 A's? All right, yeah, you're going to need both hands. Good, Elena. Remy, Mickey, good. Keegan, good. 7. All right, so I have my negative I, and then I have 7 sets of A's that I can take out. 7 sets of 2. All right, which means I have leftovers, because not only do I have a 3 that I never took out, but if I use 7 sets of 2, that means I've only used 14, I've got 1 more left over. And again, it is okay if you put the A to the 7th first and the I second. It is okay. All right, now I just want to show you real quick. All right, so we can call this number 4. All right, and I'm not going to throw any letters in there. I just want you to see, I'm going to do a cube root of a negative. Okay, it's a cube root of a negative. All right, well, that's an odd root. So that means my answer is going to be negative and not have an I. Okay, and here's why. Because if I have the cube root, okay, so that power is odd, then I can essentially make 3 negative 1s times my 81, okay? And so I can make a factor tree for 81, but I also have I have enough negative 1s to pull out a negative, okay? And you can always just create that out of thin air, right, for odd powers. But for my even powers, let me go back and show you what I mean, all right? If this was negative 81 and it was a square root, if I tried to put 2 negative 1s times an 81, what did 2 negatives make? A positive, good. And so this stuff here is not equal to a negative 81 if I multiplied it all back together. Okay? So it's only going to work if it's odd. The whole -1 thing is only going to work if it's odd. So if it's even, if the exponent, or excuse me, the root is even, you just take out an I and be done with it. If you want to try to think of what can I do and be done with it, if the exponent is odd, take out a negative and be done with it. Okay? If it's even, you take out an I. If it's odd, you take out a negative. All right? And then you break down the number. Okay? So that's what I'm actually going to go back and write it like that. All right? So for this one, I'm going to take out the negative and then break down the number. Okay? All right, and so remember, I only need 3, and then leftovers go back under. Oh, and that should be, the index does not change. Sorry about that. Okay, take a second, let that kind of sink in for a minute, and then let me know if you have any questions. What else can you do with I's? Well, you can do a lot more stuff with I's, okay? In a minute, we're going to see that you can add with them, subtract, multiply, and divide. But before we get to that, we're going to talk about, you can actually raise them to powers, okay? You can raise them to powers. All right, so let's write that down. You can raise I to a power. Okay? What do I mean? I mean, I could do I squared, I cubed, I to the 4th, I to the 10th, I to the 200th, I to the 77th. I can raise I to a power. Okay? Now, what I'm gonna show you is that when you do it, it's all built off of the idea, all right? It's all built on the idea that I is equal to the square root of -1, okay? It's all built off of that idea. So if you just have I to the first, the answer is just I, okay? So I'm going to change that to that, and then, whoop. All right, and the reason I'm doing this is because we're going to see a pattern in a minute, okay? So I to the first, that's what is essentially, that comes from square root of -1, and that can't be simplified anymore. It's just I, okay? But if I ask you for I squared, okay, well, what does it mean to square something? And I'll give you a second to type it in. What does it mean to square something, anything? What do you do with it? Should be lots of typing going on. Good. See a couple of things. Good. Yes. Good. Anybody else? What does it mean to square something? Okay, good. Yes. All right. So you guys are all telling me that you multiply by itself. So just be careful if you use the word doubled, just because doubled typically means times 2, and what we're really doing is timesing by itself, okay? So I'm just going to show you where this comes from, and then it's going to be a pattern that you can learn at the end and use the pattern. You don't have to actually write it out every time. All right, so what I mean by that is, all right, I squared can be written as I times I, okay? But each one of those, right, was actually the square root of -1. Each I is the square root of -1. Yes? What's the square root of anything times itself? That's our shortcut that we talked about. What's the square root of anything times itself? So like in our homework, we were doing like something like the square root of 3 times the square root of 3, and we took a shortcut. All right, so the square root of anything times itself is just the number underneath, right? The same thing without the square. So if I use that rule here, this would be -1, right? The square root times itself just gives you the thing underneath, okay? So what we're going to see, like you're going to be able to take a shortcut and just tell me that I squared is automatically equal to -1. You never have to recreate that, but I just want to show you where it came from, okay? All right, well, let's do the same thing with I cubed. Okay, so if I cube something, remember it's like multiplying by itself 3 times, right? All right, so then let's write that out as a bunch of square roots of -1s. All right, but you just told me that 2 of them multiplied together gives you -1. You just told me that in the last problem. But then I have an extra one. But that extra one, I can change it back to an I. And now when I multiply those, I get negative I. Okay, so again, you never have to recreate this. I'm just showing you where it came from. I cubed is officially equal to negative I. Okay? All right, and then I'm going to do the same thing with I to the fourth. I'm going to say, okay, well, that's just I times itself 4 times, which is essentially the square root of negative 1 times itself 4 times. All right, well, if I relate that to what I've been doing the whole time, 2 of them make a negative 1, and another 2 of them make another negative 1. All right, well, what happens when I multiply what's left? What happens when I actually do the negative 1 times the negative 1? Good. We get positive 1. Okay, so you're going to be able to skip all that stuff in the middle, and you're going to be able to tell me that I to the fourth is equal to 1. Now, what that means is for every single power, if I wrote it out like this, every 4 i's that I have will turn into a 1. Every 4 i's will end up turning into a 1. Okay? So if I went, let's say I did I to the 5th, all right, and you don't have to write this part down if you don't want to. If I did I to the 5th, I could essentially write it as I to the 4th times 1 more I. Well, the I to the 4th would become 1. And so that answer would just be I to the 1st. And if I did I to the 6th the same way, I could take out 4 of them, and that would equal I to the 2nd, but come back over here, I to the 2nd is equal to negative 1. And if I did this I to the 7th, it would end up equaling the same thing as I to the 3rd. And I to the 8th would be the same thing as I to the 4th. And then the pattern would repeat. Okay? So, here we go. Here's the big idea. This pattern repeats every 4 powers. Okay, this pattern repeats every 4 powers. Okay, so the 4 answers, I, negative 1, negative I, and positive 1 are the only 4 answers you're going to be able to give me. Okay, this pattern repeats every 4 powers. So if you divide higher powers by 4 and look at the decimal, okay, you can figure, let's just say you can figure it out, okay? Okay, so here's how I want you to do it, like when you're doing it on your own. This is what you should do. You should write I1, I1. and then make the 2 in the middle negative. And that's your pattern, okay? That's what I squared, I cubed, and I to the 4th are all equal to. But you just have to remember the pattern. I1, and make the 2 in the middle negative. Okay? Now, okay, so, yeah, we can actually do it with this. All right, so if you take this exponent and divide by 4, okay, 1 divided by 4, somebody tell me what decimal that gives you. 1 divided by 4. 1 divided by 4. All right, good, 0.25. Okay, so any power that you divide by, if you take that number and you divide by 4, if you get the decimal 0.25 at the end, you automatically can tell me it's equal to I. Okay? All right, what if I take 2 and divide by 4? 2 divided by 4, what decimal is that? Good, 0.5. And I guess I actually, let's put the arrow on the other end. Okay. All right. What if I took 3 and I divided by 4? What decimal do I get? Good, Nikki. All right. So 0.75 goes with negative I. Now, what happens when I take 4 divided by 4? Okay, 1. You don't get a decimal, right? No decimal. So if you don't get a decimal, it's kind of like having like a whole dollar, because if you divide by 4, we're talking about quarters. All right, so then it's just 1. All right, so what is that good for? All right, so here's my example, and then we'll do some practice together. What if I ask you for something like I to the 53? Okay, I don't want to sit there and write out I to the 1st, 2nd, 3rd, 4th, 5th, 6th, 7th, 8th, 9th. I don't want to try to figure out the pattern. Okay, so in my calculator, I'm going to do 53 divided by 4. Okay, so this is like my side work. 53 divided by 4. Y'all tell me what you get. $53 divided by 4. Good, Jordan. Anybody else? Tegan, good. Kaylee, awesome. Awesome, yes. Okay, I'm so glad that you guys are still with me. All right, you get 13.25. Now, I do not care about the 13. I only care about the decimal. Okay, the decimal. And that decimal is 0.25, yes? Okay, so that means that I to the 53, I to the 53 is equivalent, it's equal to I, because they have the same decimal, and you're done. That is the most simplified you can make it. All right, and that's the most simplified I can make it for you. All right, so whatever the exponent is, you divide by 4, and then you look at the decimal. If it's a 0.25, the answer is I. If it's a 0.5, the answer is -1. If it's a 0.75, the answer is -I. And if you don't get a decimal, the answer is 1. Okay, so let me give you a couple of problems to practice. All right, I don't like the red right now. All right, I'll give you a couple of problems to practice. All right, I to the 19th, I to the, oh, that's not a 7. On my paper, that's a, sorry, it's tiny. 32, and I to the 90th. Okay, and I want you to take a second and see if you can figure those out. Justin, you still there? Okay. Jemiah, you still there? Good. Connor? Awesome. I can see a little bit of everybody else, so I know you're still there. Oh, all right. Kaylee already told me all 3 answers. She just put commas between them. That's awesome. I'll take that. They're not complicated things to write, are they? Sorry, I was just scooting my chair. Good job, Kaylee. They are all correct. All right, so once you have them done, remember you're just typing, I mean the answers are either I, -1, -I, or +1. Very good, Remy. All right, so hopefully when you did 19 divided by 4, again, I don't care what the whole number part is, I just care about the decimal. You should have gotten a 0.75. And so then I just look at my pattern up here, 0.75 matches up with -I. So that's my answer to number 1. Okay, good, Jemiah. All right. Now in number 2, a lot of you told me you got no decimal, and you were absolutely right. 32 divided by 4 gives you no decimal. But then you need to look and match it up with +1. Okay? And then when you did 90 divided by 4, you should have gotten a 0.5 for your decimal. And so then that goes with -1. All right, so truly, 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 this is what you need to know. All right, I1, negative in the middle. And then you match them up with the decimals in order. All right. But the only answers you can tell me are the I and the 1 answers. Okay? Questions on that? All right, so you get I by taking the square root of a negative. You can raise it to a power, but you can also add, subtract, multiply, and divide. Okay? So that's what we're going to look at now. Add, subtract, multiply, and divide. If you need to stand up and stretch, run to the restroom, get a drink, do it quickly, please. Okay? All right, now, when you get into the adding, subtracting, multiplying, and dividing with I's, all right, you get into what's called a complex number. Complex numbers, okay? So it's more than just imaginary numbers. Imaginary numbers is just going to be part of it, okay? So a complex numbers are numbers that have a real number added, or subtracted I can't spell today, sorry guys. Added or subtracted with an imaginary number. Okay, so we've looked at imaginary numbers now. Those are numbers with i's. Okay, so real number and imaginary number. Well, real number is all the other numbers we've ever looked at. Okay, those are all the real numbers. Whether it's a square root or a decimal or a fraction or whatever, if it doesn't have an I, it's a real number. Okay, well, there is a standard form for writing your answers when they are complex numbers. Okay, and it looks like this. A, and I'm going to say plus or minus because it doesn't matter if it's addition or subtraction. B, I. Okay, where it's the real number first, and then you add or subtract, and the imaginary number goes second. All right, so that's going to be the standard form of how we write our answers. And you have to make sure that you do that in ALEKS, or it will tell you your answer is wrong. Okay? All right. All right, so let's get right into our operations with complex numbers. And all I mean by that is adding, subtracting, multiplying, and dividing. Okay? And it's just easier if we go straight into some examples. All right, so 4 minus I is a complex number because it has a real part, added or subtracted, and then an imaginary part. Now, I'm going to put it in parentheses because I'm going to add it to another complex number. Now, technically, I don't need parentheses. I'm just showing you that the first one's a complex number, and I'm adding it to another complex number. All right, well, this is the easy part, folks. All you're doing is adding like terms. Okay? Add like terms. And then you just need to make sure you put your answer in the right order. So you really need to add the real numbers first and the imaginary numbers second. Now, let me ask you this. Do I have to put the 1 next to the I, do you think? Do you think I have to put the 1 next to the I? No. Okay? So if I decide I would rather just do plus I, that's fine. All I did was add like terms. Are we okay with that? All right, let's make sure we can do another one. All right. 6 minus the complex number -2 plus 9i plus the complex number -8 plus 4i. Okay? So this time I'm adding or subtracting 3 things. 2 of them are complex numbers, 6 is just a regular real number. The one thing you have to be careful of here is a negative or a minus in front of a parenthesis, right? That matters. So don't forget that's really a -1 that you're going to have to distribute. All right, so we can't forget how to do stuff that we've done before. All right, take a minute and try to get like terms for me. Put everything together. Let me know what you get. All right, once you distribute that negative, you can actually, oh, good, Connor. Once you distribute that negative, you can actually just get rid of all the parentheses if you want, if that makes it easier. Okay? and then you can look for your like terms better. All right. So what ended up happening with 6 plus 2 minus 8 is they canceled each other out completely. So technically my real number part is 0, all right, but I don't have to write that. Then I can get my imaginary number part by putting the I stuff together. And so my final answer, and some of you did tell me thank you, was negative 5i. All right, questions? All right, so that's really it for adding and subtracting. If it's subtracting, you just need to make sure you distribute that negative and then add like terms. Okay? All right. Let's look at some multiplying. All right, we'll start off with something like this. 3i times negative 2 plus 6i. All right, well, hopefully you're thinking to yourself, I need to distribute that thing. I need to distribute. Good. So 3 times negative 2, and the I just comes along for the ride. All right, but then for the second part, you're going to do the 3 times 6, but you're also going to do the I times I, which means you have I to the second. What can we do with I to the second? What is I squared equal to? That's something we just went over before we started adding, subtracting. Good, Remy. Gosh, you're quick. All right. I squared is the same thing as getting a decimal of 0.5, but that's equal to negative 1. Good, Kaylee. All right, so what I really have here, come on, all right, what I really have here is 18 times negative 1. I squared is equal to negative 1, and you have to know that. And that's the one that's going to come up the most, okay? So now I have negative 6i minus 18. All right, and the last thing you have to do is make sure it's in standard form. When you get ready to type it in ALEKS, that means the real number has to come first, and the imaginary number has to come second. So you're only going to get it right if you put the real number in first and the imaginary number second. All right, questions on that one? There is an ant crawling across my computer screen. What the heck? I don't understand. Sorry. All right, questions? All right, how about, that's a little different. All right, remember what it means to cube something. To cube something. It means you're going to multiply it by itself 3 times. All right, so what is negative 2 times negative 2 times negative 2? Just do the 2's first. Negative 2 times negative 2 times negative 2. Good, Jordan. Good, Remy. Anybody else? Negative 2 times negative 2 times negative 2. Right. 3 negatives make a negative. And be careful, we're multiplying, not adding. Okay, so hopefully we all got negative 8. And then we have I times I times I, which is I to the third. But what is I to the third equal to? All right, so the whole thing with i's is that you cannot leave it to any power higher than I to the first. Okay, good. So I to the third is the same thing as negative I. And so now I have two negatives that I need to multiply together to make a positive. All right, any questions on that one? Okay. I do need to pick up the speed just a little bit. All right. All right, so here we have two complex numbers multiplied together, and it's a binomial times a binomial. So we're going to use our favorite four-letter F word and FOIL this thing. Okay? So first times first, outer times outer. Inner times inner, last times last. All right, are we okay with that much? Okay with that much? All I did was FOIL. Now I have to combine like terms, and I have to make sure that I take care of I squared over here. What's I squared equal to? What is I squared equal to? Good, Remy. All right, I squared is one of those ones that you have to know is equal to -1. And it's going to be multiplied by that -8. All right, so what I tend to do is anytime I see an I squared, I just cross the whole thing out and make it the opposite sign. Okay, so that -8 just becomes a +8. Okay, and now when I add like terms, I can put the -7 and the 8 together, and then the I stuff together. And as long as I put the 1 first and the I number second, I should be fine. All right, and I want to look at one more multiplication before we get into division. All right, so just like the last one, we're going to FOIL. First, outer, inner, last. Now something interesting happens on this one. Something very interesting happens on this one. What happens to the two things in the middle? Right? They cancel each other out. Yeah? Good, Tegan. Okay. And then the term at the end that has that, the term at the end that has that I squared, remember you can just cross that out and make it a +9 instead. And so all I have is 36 plus 9. So that one worked out really, really nice. There's not even an I left in the answer. And there's a reason that happened, okay? Do you remember in our homework that we went over earlier, when there was a square root in the bottom, we multiplied by the conjugate and the square root disappeared, okay? Well, if you look at these two binomials, they're actually the same binomial, but one's a plus and one's a minus. These happen to be conjugates. Okay? Well, if you multiply conjugates with i's involved, then the I completely cancels out. And that's going to be important when we get to division. Okay? All right, so now we're going to look at division. We're almost done. Hang with me. We got 2 more problems. All right, so it kind of looks like we can't really do any division. The problem is you can't leave an I in the denominator because I is the same thing as a square root in the denominator. All right, you can't leave I in the denominator. It's just like leaving a square root in the denominator. So if you think back to what we did for homework, to get rid of a square root in the denominator, we multiplied by the conjugate. We're going to do the same thing. Okay? You're going to multiply by the conjugate of the denominator. Okay? So even though it looks like you can't really do anything, you can't leave it like that either. You cannot leave an I in the bottom. So for this problem, what's the conjugate of 1 plus I? You guys can type this in real quick. What's the conjugate of 1 plus I? Good, Hunter. Good, Remy. Jordan. Awesome. Tegan. Good. Okay. 1 minus I. But if you multiply on the bottom, you have to multiply by the same stuff on top. And on top, all we're going to have to do is distribute. But on the bottom, we're going to have to FOIL. But that's good. Foiling conjugates should work out really nicely. Okay? So let's see. We get 8 minus 8i on top when I distribute. And then on the bottom, first, outer, inner, last. All right, what happens to the i's in the middle? Cancel out, good. And then the minus I squared turns into plus 1. Everybody okay with that? All right, so then we put it together and we get this. Now, the problem with leaving it like that is standard form says you absolutely must separate the real number from the imaginary number. So how do you do that with fractions? Well, you just put the bottom under both pieces, all right, and then you put the I after it. And then if you can simplify anything, you need to simplify anything. Sometimes you'll still have fractions. Sometimes you will get whole numbers like this. So unfortunately, if you leave it as a big fraction, Alex is not going to, like, you're going to have to keep trying. It's going to make you do it again. All right, so you have to split it up and then reduce any fractions that you can. Make sure the I goes next to it, not on top of the fraction. All right, and in Alex, there's an I button, like you don't actually use the I on your keyboard. You like choose it in the box where you like choose fraction and stuff. You choose the I from the box. All right, last one. Hang in there with me. You guys have been awesome today. Thank you for those of you who have been participating. I do appreciate it. All right, so here's another division problem. And so right away, if it's got i's in it, you need to think multiply by the conjugate. The conjugate of the bottom, not the top. So conjugate of the bottom. That's going to make us FOIL all of this. Okay? It's going to make us FOIL it all. So first, first, outer, inner, last, and then first, outer, inner, last. All right, on the bottom, the two i's cancel each other out. The minus 4i squared becomes plus 4. And on top, the plus 6i squared becomes minus 6. And then we can add like terms. And you want to put the real number first, the imaginary number second. And then on the bottom, all we have is a real number. If you still have an I in the bottom after you do this, you've done something wrong. Okay? All right, and then last but not least, you do have to split it into two parts. So all you do is put each piece on top over the bottom. Each piece on top over the bottom, and then the I goes next to the second fraction. And those two fractions cannot be reduced, so you're done. Like 1 and 5 have nothing in common, and 13 and 5 have nothing in common. Because you can't do decimals here. You need to do fractions. Okay? Did I mess something up? I see a few weird looks. Are we okay? Let me know if you have any questions. Sorry, I keep moving my chair. Okay. Any last minute questions? Just don't want to move on if anybody has questions. Since 5 doesn't have an I, thought you could. Okay, so I put the 5 with the -6 after I got rid of that I. So because the plus 6i squared just turns into -6 with no I, then I could put it with the 5. If it still had an I, then I could not. And then for the division, I just have to put the 5 under each one separately. The I doesn't have anything to do with that. It's just part of the final answer. Anything else? Okay, so let's talk. Let me stop sharing my screen. Let's talk about what you need to do starting now and then for homework, okay? You still have 15 minutes in here, all right? You cannot go 15 minutes early. In ALEKS, there is a homework 4.3. It is 10 problems that go with the I stuff, and it goes in order of how we did it in class. Okay, so use your notes to help you. Make sure that you get that done and that you know what you're doing before you start the quiz. All right, the quiz, all right, I lied, I'm going to share my screen again. All right, so homework. All right, so homework 4.3 in Alex. Okay, submit photos in Canvas. Right? Photos of your scratch work, right? Okay, but then, so that's the first thing you need to do. The second thing you need to do is quiz 4.1 to 4.3 in Alex. All right, submit photos in Canvas. All right, and all of that is due by class time on Thursday. So they're all open till 10:25, but you need to get them done. Some of you have really slacked off on homework. If you don't start doing the homework, you will not pass this class, okay? Some of you could easily have an A or a B, but you have a D or an F because you're not doing any homework. Please don't be that person, okay? All right, you guys are juniors and seniors. You need to be responsible and get it done. Some of you are still not labeling your problems. Please, you need to label the top of the paper with the homework or quiz, and you have to number your problems. Please don't tune me out on this. I need you to number your problems. If I can't figure out what problem it is, I can't count it right or wrong. Okay? Please. Does everybody know what the homework is? Okay. Now I will stop sharing my screen. And you can have your screen back to work on Alex.